The first thing that I did was show my sample space for the die roll, and that was the sample space is the set of all outcomes 1, 2, 3, 4, 5, and 6. And then I wrote the cardinal number for the sample space. Just like we did in chapter 2, the cardinal number for this set is 6, and that's actually the number of outcomes in the sample space. So you can think of it as the cardinal number of S as well. Then I was looking at this particular question: when a die is rolled, what's the probability that a 3 will be rolled? And so that's the number of outcomes over the cardinal number for S, the number of outcomes that I'm interested in, and that would be just the 3. So that was one outcome out of 6 possible outcomes. So 1/6 as a decimal in 4 digits, 0.1667. Then what probability do you get when you add the probabilities of rolling a 1, 2, 3, 4, 5, and 6? Because the probability for each outcome in our sample space here is 1/6, 1 out of 6. When I add them all up, I have 6 out of 6, which reduces to 1, which is also 1 as a decimal. What is the probability of not rolling a 3? Well, I thought if I add up all the probabilities and I get a 1, then my total probability for any of these outcomes is a 1, and I want to think about all of them except for the one that was a 3, which had a probability of 1/6. So I took the 1, which was the total probability for any of the rolls, together minus the one that I didn't want anymore, which was not 3, and I got 5/6. So that converts to a decimal 0.8333. Another way to look at it, which I want you to really think about this method because it saves us a lot of time on some experiments, but the other way to do it would be to think of the number of outcomes over the cardinal number for the sample space, and the number of outcomes we were interested in was everything but 3, so ignore the 3 but take the rest. So there's 5 of those, and it's out of 6, which is the cardinal number for the sample space. Same results, just a different way to get to it. This saves us a lot of time. You think about the total probability, which is always 1, take away the ones that you don't want, and you have the probability for the remaining ones. So that was a little bit of a shortcut.